Good morning, students. Hello. In last lecture, we had discussed about the strain energy due to the torsion bending and shear stress. Now, in this lecture, we have calculating the calculated the energy of distortion or shear strain energy. Now, energy of distortion or shear strain energy. Shear strain energy. The strain energy given by strain energy given by the split into the following two strain categories strain energies. First, strain energy of distortion. Second, strain energy of uniform compression or tension, or it is called volumetric strain energy or energy of dilation or energy of dilatation. Okay, let E1, E2 and E3 be the principal strains in the direction of principal stress is sigma 1, sigma 2 and sigma 3 respectively. Then E1 is equal to the 1 by E sigma 1 minus mu sigma 2 plus sigma 3. E2 is equal to 1 by E sigma 2 minus mu sigma 1 plus sigma 3. E3 is equal to 1 by E sigma 3 minus mu sigma 1 plus sigma 2. These are the principal strains in the direction of principal stresses. Adding the above equations, E1 plus E2 plus E3 is equal to the 1 by E sigma 1 plus sigma 2 plus sigma 3 minus 2 mu sigma 1 plus sigma 2 plus sigma 3 or sigma 1 plus sigma 2 plus sigma 3 divided by E into 1 minus 2 mu. It is equal to the this is equal to the volumetric strain. So volumetric strain will be equal to the 1 minus 2 mu upon E sigma 1 plus sigma 2 plus sigma 3. If sigma 1 plus sigma 2 plus sigma 3 equals to 0, so volumetric strain will be equal to the 0. This means that if the sum of three principal stress is 0, there is no volumetric change, but only the distortion occurs. And if three principal stresses sigma 1, sigma 2 and sigma 3 are equal, E1, E2, E3, this means that there is no distortion, but only the volumetric change occurs. So from the above discussion we arrive at the following conclusion. First, when the sum of three principal stresses is 0, then there is no volumetric change, but only the distortion occurs. Okay, and second, when the three principal stresses are equal to 1, and other, there is no distortion but only volumetric change occurs. Okay, now strain energy of distortion occurs when the sum of three principal stresses is 0, and when the three principal stresses are equal to the one another, there is no distortion but only volumetric change occurs. Now come to the next topic, which is Castigliano's theorem. Castigliano's theorem can be used in following cases. First, to determine the displacements of complicated structures. Second, to find the deflection of beams due to shearing or bending if the total strain energy due to shearing forces or bending forces, bending moments is known. Okay. Third is to find the deflection third is to find the deflections of curved beams or springs. Okay. Castigliano's theorem is stated that if U is the total strain energy if U is the total strain energy of any structure due to application of external loads W1, W2, W3 and so on at points A1, A2, A3, An respectively. In the direction AX1, AX2, AX3, AXN and due to couple M1, M2, M3 and Mn at point B1, B2, B3, Bn respectively, then the deflection at the points A1, A2, A3, An in the directions AX1, AX2, AX3 and AXN are del U upon del W1, del U upon del W2, del U upon del W3, del U upon del Wn and the angular positions of couples are del U upon del M1, del U upon del M2 and del U upon del Mn at respective points of applications. Now the proof for the theorem for point or concentrated load first of all, read this statement again. If U is the total strain energy of any structure due to application of external load W1, W2, W3 and Wn at points A1, A2, A3, of respectively in the directions Ax1, Ax2, Ax3 and Axn, and due to couple M1, M2, M3 and Mn at points B1, B2, B3 and Bn respectively, then the deflection at the points A1, A2, A3, An in the directions Ax1, Ax2, Ax3 and Axn are partial difference. If we did partial differentiation of total strain energy with respect to the W1, this will be the total deflection at the point of application of the load W1. Del U upon del W2 is the total deflection at the point A2 where W2 load is acting. Similarly, del U upon del W3 and del U upon del Wn, and the angular positions of the couples are del U upon del M1, del U upon del M2 and del U upon del Mn at respective points of applications. Okay. So according to the Castigliano's theorem, the axial deflection will be equals to the partial differentiation of total strain energy with respect to the load applying at that point, and total angular position will be equal to the partial differentiation of total strain energy with respect to the couple applying at that point. Okay. Like this: W1, W2, W3, del 1, del 2 and del 3 are the reflections at that point. A1, A2, A3 are the points where these loads are acting, and X1, X2, X3 are the deflections. So here delta 1 is equal to the del U upon del W1. Now let X1, X2, X3 and Xn are displacements or deflections at the points A1, A2, A3 An in the direction of respective gradually applied loads. Okay. Now, phi 1, phi 2, phi 3, and phi m are the rotations due to respective gradually applied couples M1, M2, M3, Mn. Total strain energy U will be equal to the 1 by 2 W1 into X1 plus 1 by 2 W2 into X2 plus 1 by 2 M1 phi 1 plus 1 by 2 M2 phi 2 plus 1 by 2 M3 phi 3 plus 1 by 2 mm phi m. Now the load W1 alone be increased by delta W1 gradually. Then let delta X1, delta X3 plus delta X2, delta A1, delta X1, delta X2, delta X3 further deflection of the points A1, A2, A3 respectively and delta phi 1, delta phi 2, delta phi 3 are the rotations of the points of application of respective couples. Okay. Therefore, change in strain energy will be equal to the W1 plus 1 by 2 delta W1 into delta X1 plus W2 delta X2 plus W3 delta X3 plus Wn delta Xn plus M1 delta phi 1 plus M2 delta phi 2 plus M3 delta phi 3 and so on mm delta phi m. Now Here delta W1 into delta x1 can be neglected. Now the total strain energy will be equal to the U plus delta U equals to the 1 by 2 W1 plus delta W1 x1 plus delta x1 plus 1 by 2 W2 x2 plus delta x2 plus 1 by 2 W3 x3 plus delta x3 plus and so on 1 by 2 Wn xn plus delta xn plus 1 by 2 m1 phi1 plus delta phi1 plus 1 by 2 m2 phi2 plus delta phi2 plus 1 by 2 m3 phi3 plus delta phi3 plus 1 by 2 phi m plus delta phi m. Now subtracting the both the equations, then delta U will be equal to the 1 by 2 x1 delta W1 plus 1 by 2 W1 delta x1 plus 1 by 2 delta x2 W2 into delta x2 plus 1 by 2 W3 delta x3 plus 1 by 2 Wn delta xn plus 1 by 2 m1 delta phi1 plus 1 by 2 m2 delta phi2 plus and so on 1 by 2 delta phi n. Here 2 delta U will be equal to the x1 delta W1 plus W1 delta x1 plus W2 delta x2 plus Wn delta xn plus m1 delta phi1 plus m2 delta phi2 plus delta phi. Now subtracting the both the equations, above equation delta U will be equal to the x1 delta W1 or del U upon del W1 will be equal to the x1, which is the deflection under the load W1. Okay. Similarly, del U upon del 2 is equal to the x2, del U upon del W3 is equal to x3, and del U upon del W1 is equal to the XL. If we proceed in the same way for the couples, we will get del U upon del M1 is equal to the phi 1, del U upon del M2 will be equal to the phi 2, and del U upon del MM equals to the phi. Okay. Now the next topic is theories of failure. There are 5 theories generally used for theories of failure. First, maximum principal stress theory. Second, maximum shear stress theory. Third is strain energy theory. Fourth is shear strain energy theory. Maximum principal strain theory. Okay. Maximum principal stress theory states that if failure will occur when the maximum principal tensile stress sigma 1 in the complex system reaches the value of maximum stress at the elastic limit sigma E in simple tension, or the minimum principal stress reaches at elastic limit in simple compression. Sigma 1 should be greater than less than equal to the sigma E for safe working in maximum principal stress theory. According to the maximum shear stress theory, failure will occur when the maximum shear stress tau max in the complex system reaches the value of maximum shear stress at the simple tension at the elastic limit, that is tau max, which is sigma 1 minus sigma 2 by 2. This should be less than the sigma 1 minus sigma 2 upon 2 sigma e by 2, okay, or implies sigma 1 minus sigma 2 should be less than equal to sigma e, where sigma 1 is the maximum stress, principal stress, and sigma 2 is the minimum principal stress. Strain energy theory. According to the strain energy theory, failure of a material occurs when the total strain energy, which is U, is equal to the 1 by 2e sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1 in the material reaches the total strain energy of a material at the elastic limit in simple tension, which means it will be equal to the sigma squared 2e. Maximum shear strain energy theory. According to the maximum shear strain energy theory, the failure will occur in the elastic where the shear strain energy per unit volume, which is 1 by 12c sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square per unit volume in the stress material reaches a value equal to the shear strain energy per unit volume at the elastic limit point in the simple tension test. Okay. Maximum principal strain theory. Maximum principal strain theory. According to the maximum principal strain theory, failure will occur in the material when the principal tension strain in the material reaches the strain at the elastic limit in the simple tension. The principal strain E1 is equal to the 1 by E sigma 1 minus mu sigma 2 plus sigma 3. If E1 is greater than sigma E by E, in that case failure will occur in the material. According to the maximum principal strain theory. Okay, thank you very much for the class.